Okay, guys, so we are going to review simple interest and compound interest real quick, and then we're going to get into savings annuities. Also, just a side note, I am going to reopen the homeworks that were due last week to be due on Wednesday, just in case you had some confusions about simple interest and compound interest. That way you can kind of get all of those loose ends kind of tied up at the beginning of this week. Keep in mind we are still having homework assignments and stuff opening this week. So if you didn't do the homework, you're kind of behind. So you're going to have to really put in a decent bit of work to get it all done this week. Okay, so first, we're just going to review kind of what interest is, simple interest, compound interest. So the interest is typically a percentage of the balance, and a kind of a big question between simple interest and compound interest is how often is interest accruing? So are we just at the end of a period applying the interest? That would be simple interest. Or throughout the time period, are we compounding interest? So if it's just a one-time thing, we can use simple interest. So for example, maybe after 6 months, we're charged interest on a balance of $250, and the interest is described as a 30% yearly rate. So for simple interest, we have I equals P times R times T. So we would have our original amount being $250, and we would multiply that by our interest rate, which is 30% annually, which is 0.3 as a decimal. And since we're not doing the full year, we're only doing half a year, so 6 months is exactly 1/2 of a year. We're going to multiply that by 1/2, right? So basically, whatever fraction of a year we're on, we'll use that fraction of an interest rate. So if it's 2 years, we'll use twice the interest rate. If it's half a year, we use half the interest rate. And that's what this R times T is doing. And then we can multiply these together in our calculator. And for this, we would end up getting $37.50. And that would be our interest charged, right? After the 6 months for 30% yearly rate, assuming that the bank is just saying, okay, after 6 months, we're going to apply whatever interest should be applied. Just one time, no compounding. But as we discussed in class 2 weeks ago, a more realistic situation is compounded interest, where basically if you have that amount sitting or your balance sitting for an entire year, they don't just at the end of the year apply the interest, they're applying it every month. And every month they're applying a fraction of that annual interest rate, right? It would be 1/12 of the interest rate. And so you're accruing interest, and the next time that interest is applied, next time interest is compounded, you're also earning or being charged interest on the interest that was already applied, okay? So then that kind of sparks the compound interest formula. And between simple interest and compound interest, the only new variable is this n here. And the n represents the number of times interest is compounded, typically each year. Our t is going to be time in years, our r is going to be our interest rate, our p is going to be our principal balance. Other difference between these two formulas is our simple interest. The answer that we get popped out is I, which is the dollar amount of interest. For this one, we have A, and it's going to be the amount in our account at the end. So if you want to find the interest, you would have to take the amount in the account and subtract off the principal. So we'll do an example of that. So basically the same problem, just now we're compounding interest. So we're charged 30% annual interest. Our balance is $250. We're working over 6 months. But this time it's compounded monthly, so we can try to figure out what we're going to be paying in interest. So we'll have A is equal to our P is $250 times 1 plus R is 0.3 divided by 12, because we're working on 12 months in 1 year. So if we're compounding monthly, we're compounding 12 times. We raise that to the n times t power, so 12 times the time in years. Well, we already talked about in the last problem that 6 months is half a year, so we would do 12 times 1/2. And we could simplify this a little bit. 250 times 1.3 divided by 12 ends up being 0 or 0.025, so we add 1 to that and get 1.025 raised to the 6th power. And then we could type that into a calculator, and we would end up getting that the amount in our account at the end is $289.92. So that's the amount in our account. If we want to look at the interest that we earned over that period, or that we were charged over that period, whether this is, an amount that you owe or a savings account, probably an amount that you owe since the interest rate is 30% annually. You would take the amount that's in the account and subtract off the principal balance, right? So just what you have at the end minus what you put in at the beginning, and everything else is going to be interest. So that's $289.92 minus 250. And so the interest that we earned is $39.92. And so notice, they're not off by that much, but when we had simple interest, and then when we looked at compound interest, the interest that we earned is different. So in one situation, the simple interest, we earned $37.50, but for compound interest, we earned $39.92. If we want to look at the actual percentage interest that we earned, we could look at the dollar amount of interest that we earned and divide by the amount that was originally invested into the account. So we could look at this $37.50 divided by the amount that we had invested, which was $250. If you type that into a calculator, you get 0.15. So basically, we earned 15% interest over 6 months. If we want to talk about this in terms of a year, this would equate to 30% annually, which makes sense with simple interest because we're exactly just applying the interest once. So if we do this, we should always get back what our annual interest rate was in the beginning because we're not compounding our interest. It's just a flat 30%. If it's 6 months, it's going to be 15%. If it's 2 years, it's going to be 60%. It's very nice like that. For compound interest, to figure out kind of this, what real percentage we made in 6 months and the approximate percentage we made annually, we'll do the same thing. We'll take the interest that we earned, $39.92, and divide by the amount that we invested into the account, which is $250. And if you type this into a calculator and round to 2 decimal places, you'll get 0.16. So that means that for compound interest, we were charged 16% interest over 6 months, which equates to approximately 32% annually. The reason I'm putting that approximately 32% annually is because over the next 6 months, for that 1 year, we're going to continue compounding. And so this percentage is more than likely, actually I can tell you guaranteed, that percentage is actually going to be higher than 32%. But if we're just using this 6 months as a baseline, and then we're kind of making an approximation, we'll just multiply it in 2 so that we have 1 year. So kind of big point is simple interest, you're earning exactly the interest that is advertised. If we're working on compound interest, which is usually what happens, the interest is actually going to be your true percentage interest that you earn in a year is going to be different. Unless you were to pay off the interest every month. But if you're not making any payments or withdrawals or anything like that, your annual interest that you actually get is going to be higher than what is advertised in the beginning. Okay, so now we're going to move into the new material. So we're not done with simple and compound interest, but we're building off of it. Now, I was just talking about if you don't make any payments or withdrawals and stuff like that. But we know that's not typically realistic. Realistically, if you have, let's say, a credit card, so you owe a debt, you're being charged interest, hopefully you're making payments. And if you don't want to be charged late fees and stuff, you have to be making payments. They have those minimum payments that are due. Alternatively, if you have a savings account, typically people don't just, drop $100,000 into a savings account and then just let it sit for 50 years. Usually what they do is they will pay $300 a month, each month, on and on and on, and they'll build that savings account. And so they're depositing money as interest is accruing. And that's actually exactly what a savings annuity is. So the first one we're going to talk about is a savings annuity. The one with loans and like credit cards, that's going to be a payout annuity, and we'll do those later this week. So a savings annuity is an account earning a percentage interest. It's going to be compounded periodically over some amount of time, while regular deposits are being made each period. So when I say regular deposits, I'm meaning the deposit that you're making is going to be the same each month. So maybe you've budgeted that, I'm putting, $300 into my savings account each month, and you're going to stick to that. So we have a formula to figure out the amount that's in the account. So this A is the amount at the end based on the size of your deposits. So D is going to be the size of your regular deposit. So that would be like, the $300 that you're depositing each month. And then we have the rest of this formula where the variables we've already been using. So R is still going to be our interest rate as a decimal. N is still going to be the number of compounds per year, and T is going to be the number of years. If you want to find the derivation of this formula, there is a video linked at the top of your homework that actually kind of discusses this a little bit. And that actually is part of your homework, so make sure that you watch the video. Okay, so we're just going to jump into an example. So here, suppose we deposit $400 monthly into an account earning 4% annual interest. So this would be like a high yield savings account. Assume that it's compounded monthly, and we're doing that for the next 10 years. And we want to figure out how much has accumulated at the end of the 10 years. And then we'll figure out how much interest we actually earned based on the amount that we actually put into the account. Okay, so I'm going to go to the next page, but basically $400 monthly, 4% annual interest, 10 years compounded monthly. So we can just use the savings annuity formula. So we've got that the amount in the account at the end is going to be equal to, we have first the amount that we deposited each month, so 400, times 1 plus our interest rate is 0.04, divided by, we're compounding monthly, so divide by 12, raised to the 12 times 10, so that's n times t, minus 1. The minus 1 is always there in the formula. And then we divide by the 0.04 divided by 12. And this we can go ahead and type into our calculator. You might want to do, step by step. You should end up getting $58,899.92. So basically, we have that amount in our account at the end of the 10 years. Okay. The next thing that we were asked is to figure out how much we actually deposited into the account, right? Well, if you think that you are depositing $400 every month for 10 years, you can just do some simple multiplication to figure out how much you ended up actually depositing. So I can take 400 times 12. That would be the amount that I deposit each year. And then I'm doing that for 10 years, so I multiply by 10. And I end up getting that I invested, like from my own money, I invested $48,000. So that's $48,000 of basically our own money. And so then if you want to figure out the interest that you earned, you're just going to take the amount that you have in the account, which is this $58,899.92, and you subtract off the amount that you actually put in. And then you can assume that the rest of it is going to be interest. So it's just a simple subtraction. And we end up figuring out that we earned $10,000, $899.92 in interest, right? So about 20% of the amount that we had at the end actually ended up being interest, which is kind of the cool part about saving over time, is the amount of interest that you earn actually can end up being pretty nice. Okay, so next problem. In the previous problem, we were like, okay, we can afford to put $400 aside for the next 10 years, figure out how much we earn or how much we end up accumulating. This problem is basically saying, okay, we know our goal. Our goal is to have $1 million by the time that we're 60. And we want to figure out how much do we need to start putting aside each month if we want to obtain this goal. And you can use the savings annuity formula. Again, just now, we don't know the amount that we're depositing, so we don't know D. And we know the amount that we want at the end, so we know A. So we just plug in those variables. So we've got $1 million is equal to, we don't know what D is, and then we can plug in the rest. So we have 1 plus our interest rate is 0.07 divided by 12. 12 times. So here, I'm going to use 42. Just kind of like assume that you're 18. If you're not 18 and you actually want to do it with your age, you just take 60 and subtract off your age. So like if you're 20, if you're 20 years old, from 20 to 60, that's a difference of 40. So then you would put 40, but I'm assuming you guys are probably around 18. So I'm going to put 42 for the number of years. So from 18 to 60, it's 42 years. Okay, and then according to the formula, we have this minus 1. Divide out by, again, 0.07 divided by 12. So I'm just plugging in interest rate is 7%. We're compounding monthly because we're making monthly payments. We're assuming stuff is monthly. And so we have all of this set up. And basically, we're trying to solve for this D right here. So we can essentially kind of shuffle everything over. So if I multiply both sides by the 0.07 divided by 12, I'll end up getting 1 million times 0.07 divided by 12 is equal to D times 1 plus 0.07 divided by 12. 12 times 42 minus 1. And so you can type basically this side into your calculator, write that down. This side into your calculator, write that down. And then you can just divide by this. I'll write the full thing out though. So we basically get that D is equal to, it ends up being 1 million times 0.07 divided by 12 times 1 plus 0.07 divided by 12. 12 times 42 minus 1. And we can do each of those pieces in our calculator. I'm just writing out, this is how it ends up being arranged. Well, when we do that, and I would yourself make sure that you can type this into your calculator with no issues, you end up getting $328.55. And so basically, if you set aside $328.55 each month for the next 42 years into an account that is earning 7% interest, you will have $1 million set up for you by the time that you are 60 years old. And actually the reason, just FYI, that I chose 7% annual interest is because that's actually the average growth of the stock market. So basically, if you invest in the stock market in a smart way, don't just invest anywhere. You should look up about investing. But if you're investing this much each month, you'll be able to get that $1 million by the time you're 60. So we can also kind of look at what's going on with how much are we actually depositing, because that's a long time to be making slightly over $300 per month deposits, and how much interest we're actually earning. And I think this one is actually kind of cool. So I'm going to put fun fact. So the amount that we actually invested would be this $328.55 per month, so times 12, per year, and we did 42 years, so times 42. And if you do this multiplication, you end up getting that in total, you ended up investing $165,000 or $165,589.20. And I just want you to kind of notice that over time, you invested less than $200,000, but over time, you have at the end this $1 million. That's really cool. So like you put in less than what ended up being 20% of the balance, right? So the interest that you earned would be equal to the $1 million. Subtract off this $165,589.20, and it's $834,410.80. That's how much you earned in interest, right? So that's a lot, basically, for like pre-planning, right? Okay, so these problems are nice to test out different situations, especially for your financial planning. Like you definitely should plan out what you should be putting into your savings account to earn, have a pillow, when you get your career, it's a good idea to have at least a year of your salary in savings, just in case anything happens, you lose your job, you get injured, anything like that, like at a minimum once you get established. And you can use this to plan that out. But using the formula might be kind of tedious, right? Especially if you're wanting to test out, different situations. So there is a TVM calculator, which is a time value money calculator. I'm actually going to link one in web courses. So if you go to the module for this week, there will be a link that says TVM calculator, and you can click on that and open up the calculator. And you'll see a place to kind of fill out some different information. And I'm going to kind of try to tell you in the notes right here how to use it. So you'll have your present value, which is basically your original amount in the account. And I'm just going to compare to the last example. In the last example, we were assuming that we started saving from nothing. So our original amount in the account would be $0. And then you can put in your payments, which would be your deposits in the situation of a savings annuity. And this one we didn't actually know. So this one we would have left it blank if we were trying to do the previous problem. The future value is the amount that you're going to have at the end. And we knew this one, and it was $1 million. Your annual rate is going to be your interest rate, and you type that as what it would be as a percentage. So for ours, you would type 7, not 0.07. You would type 7 for 7%, because they're already accounting for it being a percent. And then you put your number of periods, which is actually equivalently N times T. So for us, we would have typed whatever 12 times 42 ended up being. I think it ends up being like 508. Let me double check. 504. Basically 504 months went past, and we were compounding monthly. And you'll see a little drop down for compounding where you can select monthly, daily, yearly, quarterly, semi-annually, stuff like that. And you would select monthly. And then for each of these, there's a little button. And basically, if you fill out all but one of them, and then you click the button for the one that you don't know, it will auto fill in what that unknown is. And so you should see the $328 and something cents pop up right here. And it basically does everything for you. You just have to type in your information, right? So here's an example that you can kind of test out using that calculator. If you want to navigate to that calculator real quick and try to do this problem, I would suggest you go ahead and try it. I'll write down the answers that you end up getting in a second, but pause the video if you want to try it. Okay, so for this one, if you type that your deposits are going to be $100 per month for 50 years monthly, so keep in mind the number of periods that you type in should be whatever 50 times 12 is. 7% interest rate, you would select that you're compounding monthly, and you put your beginning balance at 0. Your future value, which is the one marked as FV, your future value or your ending amount that's in the account will be $544,807.09. So that's how much will be in the savings account after the 50 years. And then from this, this isn't going to be in the calculator. This is the piece that you get from the calculator. We can kind of figure out what our interest that we earned would be by looking at the amount that we actually put in, which would be the $100 every month, so times 12 times 50 years ends up giving us $60,000. And then when we look at the interest that we ended up earning, we would take the future value, or the amount that's in the account at the end, and subtract off the $60,000. and we would get that we earned $484,807.09. So that's how much we ended up earning in interest in situation A. For situation B, when you type in $500 per month for 10 years, so do 12 times 10, so 120 periods, at a 7% interest rate compounded monthly, you would end up getting that your future value is $86,542.40, which is significantly less, even though when you look at the amount that you actually invested, so this $500 per month times 12, because it's monthly, times 10 years, we actually ended up investing the same amount of money, so $60,000. And you can see just how different our future value is. Even though for, the person in situation B, they're putting in $500 a month, like that's a decent chunk of change, versus person A who's only putting in $100 a month. But person A is putting it in for substantially longer time. Even though it ends up being the same amount of money that they invested, they basically give that money much more time to grow with interest. And so if we look at interest and we take our future value and subtract off the amount that we invested, or the $60,000, we end up getting that we earned $26,542.40 is the amount of interest that we earned. And you can just see how different these numbers are. Like, wow. So moral of the story, start saving sooner rather than later, even if you can only afford to put very small payments in. Like even if you can afford to put, $50 aside each month, and you start now, it will save up fast. It's going to seem slow at first, but once you get a decent amount of money in the account and you let it sit, it's going to grow pretty fast.